short video, I'm going to show you how to use Python code to perform Gaussian elimination. The minimum requirement is you should have Google account and you don't need any coding experience. So to access the code, you can type in this web link, github.com blah blah blah, and then it leads you to a GitHub coding repo. And the next thing is you scroll down to second item. Next to it is a link you can click, and this gives you the Python code. Of course, to run it, you have to run it on Colab. In other words, you need to load the code to the Colab by clicking this blue tab. And if you scroll, just quickly scan this code, the first part code is saying that this is just import necessary packages by Python, so you don't have to worry about what it means, and just copy and paste for your code. And the second part is explanation of matrix operations in Python. So after that, we used one example for Gaussian elimination. So we started with this 3 by 5 matrix given here, and after some step-by-step forward elimination and backward elimination, we ended up with another 3 by 5 matrix, which is supposed to be reduced echelon form, row echelon form. All right, let's start. So you may click on this blue tab, and then it automatically goes to Colab with the code. And to run this, of course, you can directly run this here, runtime and run all, but you'd better save a copy in your drive, which allows you, if necessary, you can modify the code. And then you want to try if this can be successfully implemented. So runtime and run all. If there's no message, no error message pop up, then that means it's successful, the code is successful. Let me do a little bit more explanation with new notebook. To do that, I'm going to go to File and New Notebook. Then it will open up with New Notebook. For example, in the first shell, you can try 1 plus 1. Is that smart enough? First time, it's quite stupid. Takes a few seconds to figure this out. But this is because the first time it connects the backend server. From second time, if you ask more question, like difficult question, they can do it instantly. So you can believe any mathematics for Python coding. And to start with, I'm going to copy all the packages we needed in the Python coding for this matrix operation. You don't have to know what it means, just copy and paste. And the way we put matrix to the Python coding is using NumPy array. So what I do is I'm going to put it here in the new coding shell. And you want to check if the right matrix was input into the computer. So you just type in the name of the matrix in the new shell, and then it will display whatever it has. Now, let me explain a little bit about indexing. So in mathematics, we have indexing from 1 to like this. So every indexing is starting from 1 in mathematics, but in coding, in Python coding, everything indexed from 0. For example, if I say 0.3, then this, in our language, in math language, this is the second row and column 4. But in Python language, you should take off 1 from each index. So this is rows 1 and column 3. So let's try. So I want to read row 2, column 4 in math index. Then for your code, what you do is A is the name of the matrix, and the index is 1 and 3. Then it will display 0.3. Now if you want to read the whole row, the whole second row, then you just give 1 index, but the index is not 2, but 1 from Python index. And you can also do other operations. For example, you can do like, I want to multiply each entry of the second row by 4. Then you can just do like this. So in our math class, we write it as following. Write R2, row 2. Yeah, I can just write briefly. Row 2 multiplied by 4, which replace row 2. To do that, remember A1 is changing, replaced by A1 multiplied by 4. That changes the matrix, and you want to see if the matrix is changed correctly, so you can check. The first row, the second row was changed by 4. And you also, maybe you want to eliminate this 1 from the matrix. Then what you do is maybe from R2 is subtracted by R1 times 5, which replace R2. To do that, you are going to do A1 is replaced by A1 minus A0, which means row 1, times 5. And then you can check if this is done or not. So the second entry is 0 now. So if you go back in our code, then this is original matrix, and then what you did is just row operations, so step by step. This is scaling, rescaling the first row, and then a few other EROs. You can read it by yourself.